Okay, let's get started. What I'm going to do is show you how to solve lab problem 8, or perhaps we'll just, a better way to say it is we'll solve it together, but I'll do the leading on that. Okay, so lab 8 has a single problem in it, right here, P5.18. And here's a description of the problem, thanks to Kanika, who sent me this from her cell phone. Okay, so let's look at this and try to parse it, try to figure out how we're going to tackle a problem. So the first thing that I'm going to think about is I'm going to create a shell for the solution to this problem to evolve. And that means I'm going to create a Visual Studio project, or if you were working in Linux, you would create a folder and a main.cpp file and so on. Today we're going to work in Visual Studio, and we want to create a shell that we're going to use for the solution to evolve in. So the first question is whether this is going to be a console application or a graphics application. And well, it's a graphics application. They show an image of a house that you need to draw, so we know that it's a graphics application. So let's go ahead and create a project, Visual Studio project for a graphics application. And we'll call this P5, was it 19? 18. So this will make it an empty project. It's a Windows application as opposed to console application, or as opposed to the other choices. And we need to turn off Unicode support, because we're using the author's libraries that do not work with Unicode. Now it's a graphics program, so let's get those library files in there as usual. Alright, we copy those files outside of Visual Studio. If we did the copy and paste inside Visual Studio, we would get references to the files, or shortcuts to the files, rather than copies, actual copies. And that might be okay for the library files, but it won't work for the main.cpp file. But the reason that we have you do it to follow this procedure is because we can check out your code and build it and run it easily without having to resolve those desktop references. I mean, not desktop references, but without those shortcuts. So let's go ahead and paste. Sorry, this is I can't remember what I was doing. Let's add existing items. We're in P5.18. Here's main. So we're including this cannonball. Let's get rid of that. Well, maybe we'll reuse that. These are our screen coordinates. We can look at that. and just to make sure everything works. So we'll do cwin 0.00. I like to put a space there. We want to make sure that we have our project set up correctly. So we want to get a quick build and run. Let's see, I'll set this as the startup project. Now I can use the hotkey. There it is. That's the origin. So we have the beginning of our solution. Let's try to read through this problem statement again and then figure out what to do. So design a class house that defines a house on a street. Okay, so right away I'm going to just dwell on that statement, a little bit. I'm going to write some code just as I have it and keep it in my memory, so as I go forward through the rest of the problem statement I can remember that easily. So we need a house class. So that's straightforward what to do at this point. Let's go ahead and add a new class. You can add a class here. I'll show you how to do that. Alright, so that's a C++ class. And what is going on here? Doesn't give me an add. There it is. Class name is house. And see, it's going to auto-generate this house.h and house.cpp file, and it's also going to put in some extra code. I usually like to start from scratch, but this is good. This is particular just to Visual Studio. This doesn't work inside the other operating systems or the other compilers. So what this says is that if this file has already been included, then don't re-include it. If you're trying to include it again, then don't include it again. But the way we do this in a platform-independent way is a little different. It looks like this. If ndef, if not defined, something, you make it up yourself. This is a typical convention, naming convention for this. So if house_h is not defined as a preprocessing symbol, if that preprocessing symbol is not defined, then let's define it and then go forward. Otherwise, this is ndif, right? Otherwise, don't do anything. So if we include this file once, the first time we include the file, the preprocessor will, now the preprocessor, that's a step where we do an initial pass through the code before we try to compile it. I mean, it's like compiling, but it's just the first phase. So we read through the code and we look for these statements that start with the sharp sign. And that's a signal to the compiler that this is a command that should be executed during the preprocessing phase. So the preprocessor keeps a table of names, and if house_h is not in the table of existing names, then add it to the table, define it here, and then carry on and include the rest of that text, and then that's it. And then if we were to try to include this a second time, and the preprocessor is going to reach this point, and it's going to say, well, if house_h is not defined, well, it is defined. Oh, house underscore H is defined. So I'm not going to do what's in this block. So if ndef, if house underscore H is not defined, do that or include that. If it is defined, don't include it. That's how that works. Visual Studio puts this void in there. This is okay. You can leave it in there. It's just not my style. I take it out. It's optional. So this is the constructor and a destructor. You'll notice that it creates this, this automatically inserts this include statement, and it creates a definition of the constructor and the destructor. Once again, that void data type is optional. I don't like to put it in there. So the constructor does nothing, the destructor does nothing. Then we would have something like where we would create a house here. But now, as you can see by the red underline, this symbol is not defined, so we need to define it. We do that by including the header file. No, that's the reason I left that cannonball statement there, but let's take that out. All right, let's see if that builds. Okay, good. So we just digested the first sentence here, which is design a class house that defines a house on the street. So we need a class called house. Or we created the shell of a class, we call it house. All right, that step is done. A house has a house number and an XY location where X and Y are numbers between -10 and 10. So that's a statement about the attributes of the house, or the data that a house object contains. It has a house number and it has an XY location. Let's go ahead and digest that in our code as well. So it has a number. Maybe that's a little redundant. We can just call it number. Hi. So we have an integer called number. Well, maybe it's an unsigned int. I mean, it doesn't matter that much, but a house isn't going to have a negative integer, right, as a number. And then there's an XY position. Positions are, those are geometric locations. Those are real numbers. So we use a floating point data type for that. And the alternative to creating the X and Y would be to create a point called location. You could do it like that. I'm not sure which one I would want to do. Maybe this is better. Any opinion about that? Well, we haven't really looked at the implementation, the problem yet. So let's just keep that commented out. That's an option. We can go in that direction. Now, these should be initialized in the constructor. So we do that here. We can use an initialization list like this. Let's give the house a number 0. Let's give the X value a value of 0 and the Y value a value of 0. That's called an initialization list. That's roughly equivalent to this. It's done at a different time during execution. Alright, this code here is for our purposes equivalent to this code here, but there are some situations where there is a difference. Those are kind of subtle situations that we're not going to talk about. In general, this is the best approach to use to initialize member variables in the constructor. And so I'm going to just comment this out. Here's a comment there. Let's see if it builds. Looks okay. So we're building a program that that has a house class in it. We know it has these three attributes. And it has here, read the next sentence. The key member function is plot, which plots the house, and then it shows what the house should look like when we plot it. So there's going to be a plot function. And by the way, normally we hide the member variables inside the private data section. And we expose to the outside code what we want to expose. In this case, it'll be the constructor and the destructor. So this section is started with this keyword here, public, with a colon. And then we declare the private section down here. Now there's a function called plot. And plot will not return anything. We just call it. So we need to implement that. And it looks like this. Void. We're in the house class. Did I use uppercase P? Plot. I used a lowercase p here. You know, in C++ code, especially on Windows, I see a lot of functions being declared with uppercase letters, and then there's also a lot of programmers that use lowercase letters. So there's no very consistent approach there. In the Java language, it's different. There you see almost universally programmers using lowercase for functions. And the reason for those type of conventions is that it helps you read the code more quickly. Because if you see an identifier and see that it has an uppercase letter, then it suggests something like it's a class. It's not a function. That's just the impression it gives you quickly, if that were to be your convention. Obviously, the important thing to do here is when you're writing one program, that you should be consistent in what convention that you use in that one program. For small programs, it's not going to matter that much, but when the code gets large, these type of coding conventions become important to follow. Well, to establish first, and then you decide what your convention is going to be, and then you follow it. So here we have plot. So plot will do something like, let's just stub it out. Let's plot a single point, right? We don't want to do the whole thing all at once. Let's just draw one thing at one point, and that'll represent the house at this point in time. Now the problem is this point is not defined, so we need the header file for that. It's up here. And now it builds. Now we can evolve the test code a little bit. Instead of printing this 0.00 here, let's go ahead and plot the house. So we should get the same result, which is a a dot in the middle of the screen. There we go. So we're moving forward. Alright, so we have the beginning of this house class with the plot function and its member data. Let's keep reading. Next, design a class street that contains a number of equally spaced houses. So there's a class street. I don't have to read anymore to do the next step. We need a class called street. Let's go ahead and do that. I'll do it this way again. And then it'll look something like this. We're going to make this platform independent as platform independent as possible. So here we don't want to use there's some danger in copying and pasting that. We don't want to use the same identifier for the street header file, otherwise there could be a bug. And once again we have this stuff, and I'm just converting it into my style. That should build. Design a class street that contains a number of equally spaced houses. An object of type street stores the first house, the last house, which can be anywhere on the street, and the number of houses on the street. So there it's telling us what the member data is going to be for this street class. Let's read that one again. An object of type street stores the first house, the last house, and the number of houses on the street. So there's 3 data items. Let's go ahead and just capture that information right away. The first house, and this is I'm going to put this in the private data section. This is the state that the instances of the class represent. So we're going to hide those away. That's just a general rule of thumb that people try to follow, not always. So there's the first house, so that's a house. It's going to be called first house. There's a last house. See how the names, they just roll out here, right? First house and last house, and then number of houses on the street. I'll make that an unsigned integer. Doesn't need to be signed. An unsigned integer, which is number of houses. I'll say on street, just to reduce the need to add in comments. Now, these data members should be initialized, and the thing is, for the houses, so we'll need some kind of initialization there. Let's go ahead and do that. Here's so our street is here. So we have the first house, and we have the last house, and we have the number of houses on the street. Let's say the number is 2, just to give it a simple number. And then the thing is, here we're initializing the houses by calling the the no argument constructor, which is what we have at this point. But we'll probably be changing that. So when we create a house, we'll pass in that data. In fact, when we create a house, I think what we'll need to do is pass in this information. Let's go ahead and do that now. Well, let's wait on that. Let's wait. We're not sure what the problem is asking yet. Completely. The street plot function needs to make the intermediate house objects on the fly because you don't yet know how to store an arbitrary number of objects. So we can't, in other words, at this point in the book, the author has not introduced a means to store an arbitrary number of objects. If we wanted 1,000 houses, how would we create and store 1,000 houses in our code? Well, up to chapter 5, we don't know how to do that. But when you read the chapter on vectors and arrays, then you'll see a way to do that. Well, if we want to create 1,000 houses, well, we could just create 1,000 houses and store them on a vector of house. So we know how to do that. Or an array of house. We declare the array to be a size 1,000. But we don't know that yet, so that's the reason for this awkward formulation of the street class. We just have the first house, the last house. We don't know how many. We know how many there are in between, but we're not going to pre-create those. We're going to create those on the fly in the plot function when we go to draw the houses. So there is a plot function, by the way, so we're going to need that. Let's put that in there. So let's use a similar implementation to what we did in house. Actually, that's not a good idea. Let's do it like this. So we're defining the plot function for street. So I mean, I've read this problem already, so I don't remember whether this was stated or not. Use these classes in a graphics program in which the user clicks with the mouse on the locations of the first and last house and then enters the house numbers of the first and last house and the number of houses on the street. Then the entire street is plotted, so we have to plot the entire street. Let's come back and parse that part. First, let's just have it. I think we can do this. We'll just have an empty plot here. Let's just see if that builds. No, that does not build. Let's see what's wrong. So inside street.h, in line 12, there's a syntax error, a missing semicolon before first house. It's saying there's a missing semicolon before first house. Does anyone know the problem? I know this problem, that the compiler's not giving us a very good error statement. It's not really helping us solve the problem. It tells us where it's struggling when it hits that point. It says, I can't figure that out. And this is so common, so I'm just going to let one of you come up with a solution here. What's wrong? Very, very common problem, and the compiler doesn't do much of a job at all at telling us what the problem is. What's that back there? Solution? Why doesn't it like that line back here?
You have to include the house.
Exactly. The compiler doesn't know what house is, because when it does is it compiles this file. It's called a compilation unit. It compiles this on its own. it doesn't automatically include the definition of the house class when it compiles this file. Remember, it compiles one file at a time. And for each file it compiles, it generates an object file. And then it links the object files together. So we're going to need to include that. Include the header file. The header file tells the compiler what the interface to the house class looks like. What are the functions that I can call? What does the constructor look like? What are the functions I can invoke? What are the arguments that they take? The header file has that information. The compiler's going to go, hey, I don't have the definition of house. We're going to link to that later on. But you told me what the interface is like. So in your code, when you create an instance of house, it has to be, the format you use has to appear as one of the constructors in the header file. All right, that's it. Now that worked. All right, let's come back and that last part there. Let's get that last part figured out. Use these classes, okay, street and class, and they're incomplete. So we have a street and a house class. Use these classes in a graphics program. Well, we already set that up. We got a graphics program set up. In which, now here it comes. This is what the user is supposed to do. The user clicks with the mouse on the locations of the first and last house. So that's two things. We need to prompt the user to click the first house location, click the last house location. Actually, so we don't have to remember it, let's just write it down here. And it'll look like this. Ask user for first house location. Ask user for second house location. The user clicks with the mouse on the locations of the first and last house, then enters the house numbers of the first and last house. Ask user for number of the first house. Ask user for number of the last house. All right. Put those in there as comments. And the number of houses on the street. Then the entire street is plotted. So also ask user for the number of houses on the street. And then plot the street or draw the street. Okay, that's how I would translate from the problem statement to into our solution. So ask the user for the first house location. So we do that with cwin. And what do we do? The first house location, that would be, how do we get that? Any suggestions? You have to get the coordinates, but they're going to click in the window. Yeah, get mouse. So remember, this is this cwin object here. It's got these functions in there, and this is hidden away. I don't know what that symbol is, but I think that means private. And these are the public members of the cwin object. And one of them is a function which is getMouse. That's the one we want. GetMouse takes a string. Click on location of first house. Click on location of first house. And that'll return a point. And then we do the same thing for the second house. I mean the last house. Click on the location of the last house. So then we get another point. Ask the user for number of the first house. Or we should say the number of the first house. So that's going to be an integer, and I'll call it number of first house. That's also done in this CWin object. So it's going to be something like get something, right? Just like getMouse. So here it is, getInt, get integer. And we'll need a string. Enter number of the first house. Ask the user for the number of the last house. Enter number of last house. Number of last house. So we have 4 pieces of information. One more piece. Ask the user for the number of houses on the street. Number of houses on street. Enter number of houses on the street. There it is. We got the information we need from the user. Now we need to use that to plot the street, right? So which would be here. We need a street. Plot the street. Well, we're going to create the street first of all. And then we're going to plot it. I'm going to draw it. Oh, this issue right there. Street is undefined. Everybody knows the problem, right? That side of the class? What's the problem? Huh? We need to include the header file. Good. It's undefined. We need to include the header file so that it becomes defined for this compilation unit. There it is. Click on the location of the first house. Click on the location of the last house. Enter the number of the first house. Enter the number of the last house. Enter the number of houses on the street. That's it. Now we need to draw the first house, the last house, and the houses in between. Let me see that. That's it. Alright, so let's go ahead and do that. Now, this information here, when we have the don't need that. When we get the first house location, we don't have enough information yet to make the house, but when we get the number of the first house, we can then make it the house. In fact, there's I'll put in some intermediate steps in here. So I'm going to create the first and last houses, and then I'm going to create the street, and then plot the street. That's how I'm going to do it. Create the first and last houses. There's a house called first house and a house called last house. And then create the street. Now the street, the thing about these houses, we're not passing in the information. When we create the houses, we need to pass in that information that should enter into those data members that define what the house is. So we're going to have the location, first house location, and we're going to pass in the number of the first house. The same with the last house. But now we have a build error because the constructor is not defined to take those values. Well, let's go ahead and work on that. Let's solve that problem. So now what we're proposing is a constructor that takes takes a point called the location and an integer which is called the house number. I'll just call it the number. I'll call it house number. And we'll use that to populate these data items here. And we could change this to make it easier. We could just store location and pull out the X and Y on the fly as we need them. But I think to do calculations, it's easier for us to keep it like that. So when we pass the point location in, we'll pull the X and Y out and store the X and Y separately. That'll just make the plot function simpler to implement. So let's adjust this. And then so X is actually not going to be 0. It's going to be the location dot get X. And Y will be the location dot get Y. And the number will be the house number. There it is. You know, if this is difficult for you to read or understand, you can always do this. Just do it like that. Is that easier? I got some nods back there. But as you go along, if you stick with this language, and you're going to need to use the initialization list. I'll just go ahead and do it like this. Just it's because we want to focus on getting the logic down. That's easier to look at. Okay. And it doesn't matter to us. And a destructor is something that's I'll talk about later. The plot function, now this is where we plot the house, so let's not worry about that right now. Let's just continue to plot a point, but hey, let's make it a point that's at XY, just to show where the house is going to go ultimately. All right, let's see if that builds now. Syntax error. Identifier point. Just going to double click that. So point is not defined here. And because we didn't use point in the header file, we used point inside the house class. And what we can do is grab this include. In fact, we can delete it from there because we're going to include house.h. So that means we'll include everything that house.h includes. So let's go ahead and include the definition of the point class along with the other graphics classes. House. Here's another error. The error is in street.cpp line 6. House. No appropriate default constructor available. See the problem there? We defined in the street class, we're creating an instance of house. We were relying on the default constructor, but we just modified the house constructor, so we no longer have a no argument constructor. We now have one constructor for house that takes these two arguments. So it's right here. Like let's make this easy as well. Let's go the first house. Actually, I don't think that's going to work, right? Let me think. We can't just do the following. This is not going to work. How do they do it in the book? I don't see how to get away. We have to use an initialization list here. So when we create an instance of street, we need to know how to create the first house and the last house. I think it's a little tougher. Does the book talk about copy constructor? No? I'm trying to figure out how to make this simple. So we have first house. The first house can take a point. Let's just get it to work first. That's a point. The last house and a number. The last house takes the same thing. And the number of houses on the street. There we go. So that works. Yeah. This is where it gets hard to explain. There's no simple solution here. If we stick with the initialization list, we can get it done. Let's try that. All right, so we have this builds, and but here when we create the street, we should be passing in the first house and the last house. We should pass in the data that we have that defines the street. That didn't work. So the information that we have that we need to plot the street is the first house, the last house, and how many houses in between. So we need to modify the constructor for the street class as well. So we have a first house, a last house, the number of houses on the street. There it is. That builds. All right, let's see. Let's go ahead and the first house. Does the book talk about copy constructors? Does the book talk about copy constructors? Can I see your book? This is the chapter 5. I'm gonna pause that. I'll just go forward here. Alright, so what we want to do actually, we don't want to pass in all this stuff here. Just pass in we want to make a copy of the first house here. Make a copy of this last house. And then the number of houses on the street goes here. Number of houses on the street. There we go. I think this will work. It does. See, because what it does, it generates what's called a default copy constructor, so that we can copy the first house that's being passed into the first house that's a member variable. All right. So we create this street, and then we call plot on the street. So let's take a look at the street's plot function now. What we need to do is just get there. So we have the first house. Let's call plot on that. And let's call plot on the last house. Here's the first house, here's the last house, here's the number of the first, the number of the last, the number of houses on the street. There's the first house, the last house. Now let's figure out, the hard part is calculating how many additional houses to draw and where their positions are. Drawing the house, the rectangle and the square, I think that's easier. So let's figure that out. So here's the plot function, and then we have, let's do it like this. How about this? Number of other houses to draw. Well, that'll be the number of houses on the street minus 2, right? That's how many other houses we need to draw. Now, I'm going to go back on that confusing point here, and I'm not going to get into the details because we don't have time and it's too advanced. I'm going to show a form of this constructor that's more consistent with the other code that we wrote for the house class. Let's try to make it look like this. We'll take out the initialization list and we'll put it in this form just to be consistent. Remember, I talked about this last time about the implicit parameter. We can do this to keep the two things different. If that's confusing, it usually is for people, but later it's the best way to do it. We can call this the first house arg, the last house arg, the number of houses on the street arg. We call it like that for argument. Now this will not compile. Because by moving this out of the initialization list, the compiler is going to generate code that creates instances of the houses before it does this assignment. And so it needs to have a what they call a default constructor or a no argument constructor. So you need to put that in for this code to work. It's not the way I would do it. I would use initialization list, but I'm going to show this to you anyway. This may be how you're approaching the problem. So let's define a default constructor. And it doesn't really need to do anything. This is what's in there. There's a number and an X and a Y. It's nice to put things to a known value, so I'm going to put everything at 0. Alright, now we have a build. Once again, we wouldn't need the default constructor if we used the initialization list here, because the compiler would not generate code to call the default constructor. We call the alternative constructors, which we're indicating in the initialization list. Okay. I know this is a confusing point. Alright, I'm going to leave it like that. And let's draw these other houses. Let's go ahead and draw the other houses. So we're going to need to, for each of these, we'll create a new house. And we'll pass in the location. And we'll pass in the house number. And then we'll plot the house. That's how we'll do it. But we need a house location and a house number. So the house location is a point. We'll figure out what point to give it later. And the house number is an int. And we'll figure that out as well. Just give it a 0. Now here, there it is. So I just printed it, plotted that one house in the middle, and or however many houses, whatever this turned out to be, I plotted it in 0, 0. So what we're going to need to do is figure out the appropriate x and y value. So we have a line between the two houses, and we need to space out the points in between so that it works. We need to calculate the quantities dx and dy. I have 5 minutes to go here. And let's do it. And then we'll start with something like this. This is our first. This would be the location of the first house. So this would be the first house dot x. Let's call it get x, and and y would be first house dot get y. Let's pull those positions out, and then we're going to calculate dx and dy. Those will be the same. We're not going to change dx and dy. Those are the same. What changes is x and y. So dx and dy, we have to calculate these. Let's just call them 2 for now. And then in here we take x and we add the dx. We do the same thing for the y. And that's the position of the next house. Of course, we have to have our house number as well. And let's put that out here as well. Let's put the house number here as well. And we'll make that the house number of the first house. So you get number, do like that. So we'll need those functions. This is get number, and this is get x. This is get y, and get x. I'm just going to put it right in the header file. Very simple. Same with y. Same with the number. This is get number, return number. What's wrong with that? Oh. Had a parenthesis instead of a brace. I think I had that problem here as well. And in fact, this is not needed. And that builds. And coming back to the street, we have what we here have. We don't have this calculation, this dx and dy, but this is going to be the dx will be the will be the last house dot get x minus the first house dot get y and we have to divide by something. What do we divide by? Number of houses on the street minus 1, something like that. And similarly for y. Oops, this should be get x. And I'm not going to go into those details because we don't have time. Is that everything? I think it is. Alright, here's the first house. Here's the last house. The number of the first house is, say, 4. The number of last house is, say, 7. Number of houses on the street, I'll say 4. Look at that, it worked. Amazing. Let's try a different number. First house, last house, number of houses, I'll say 7 houses. There it is. It's working. Now we just need to draw the house instead of drawing a point. And that would be done in here. So, that would have to work out those details there. It was a hard problem, right? Or not? Does it seem okay? Kind of a lot there. I did this problem 9 years ago, so I remembered it. And I think that it introduces a lot of issues around classes, using classes in your program. I think it raises some issues and uses aspects of classes that are difficult to understand. So as you go forward with this, you need to be kind of patient and persevering, and do as much reading and experimentation as you can to grasp this thing called object-oriented design, a programming language in which you use the classes and objects available in a programming language. And as we continue on in this course, I'll try to explain in more detail. So, yeah.
Can you scroll up a little bit?
Okay.